Hello everyone. I'm sure you must have watched my videos on the MATLAB activities for classes 6 to class 11. Now it is the time that I've started making videos for class 12. I'm sure they are going to be helpful for you. So let us see the first MATLAB activity for class 12. The objective of the activity is to verify that the relation R in the set L of all lines in a plane defined by R is equal to L, M such that L is perpendicular to M is symmetric but neither reflexive nor transitive. So what do we need for this? The material required is the colored sheets, the different colored pens, the geometry box, and the adhesive. Let us see how do we go about it. We take a colored sheet of paper and we draw lines randomly on the sheet such that some of them are parallel, some are perpendicular to each other, and some are inclined as shown in the figure 1. What is figure 1? The figure 1, we'll be taking a sheet of paper and on that let us draw some lines. I'm just randomly drawing lines, few of them being perpendicular to each other. You can see this line I have drawn is perpendicular to these 3 lines. I'll take up few lines which are inclined to each other. Some of them are going to be parallel to each other. This way I'll just make a few lines. Now this becomes my figure 1. Let us go to the next step. Let the lines be named as L1, L2, L3 up to L8. So I'll just start naming the lines. This is first line L1, L2, L3, L4, L5, L6, L7, and L8. So I've just named the lines for the figure 1. Now clearly if you see L1 is perpendicular to the line L2, it is perpendicular to the line L3 and it is perpendicular to the line L4. Okay. So you can see this line is perpendicular. It is perpendicular here also and it is perpendicular here also. L6 is perpendicular to L7. This is L6 and this is L7. So clearly this line L6 is perpendicular to L7. Now L2 is parallel to L3. If you see this L2 line, L3 line, it is parallel, they both are parallel. L3 is also parallel to L4 and L5 line. This L5 line is parallel to L8 also. So can I say that L1, L2, what was the relation? Relation was perpendicular to. So is L1 perpendicular to L2? Yes. So that means L1, L2 is an element of R. What about L1 and L3? L1 and L3, are they both perpendicular to each other? Yes, they are also perpendicular to each other. So I can say that L1 and L3 belong to R. What about L1 and L4? L1 and L4. So again, this angle being formed is 90 degrees. So I can say that L1 and L4 are also elements of R. What about L6 and L7? L6, L7, this also belongs to R. L6 is perpendicular to L7. So L6, L7 belong to R. So let us see the observation. This was the figure 1 that I had made. Figure 1, no line is perpendicular to itself. So the relation R, which is given by L, M, such that L is perpendicular to M, is reflexive or not. Now, what is the reflexive relation? That the relation holds for itself also. If I say a line is parallel to itself, that means is parallel to is a reflexive relationship. Let us check for this is perpendicular to relationship. Is line L1 perpendicular to L1? No, it is not. Is line L2 perpendicular to L2? No, it is not. So I can say that since in the figure 1, no line is perpendicular to itself. So the relation R for L, L such that L is perpendicular to M is not reflexive. Okay. Let's come to second observation. In the figure 1, L1 is perpendicular to L2. Is L2 also perpendicular to L1? Yes. If L1 is perpendicular to L2, that means this angle is 90 degrees. So L2 is obviously perpendicular to L1 also. So we will write here, yes. I know that L1, L2 belongs to R. L1 is perpendicular to L2 and from that I can conclude that L2 is also perpendicular to L1. So if L1, L2 belongs to R, then L2, L1 will also be an element of R, will also belong to R. Similarly, if L3 is perpendicular to L1, does it imply that L3 is also perpendicular to L1? Well, let us check. L1 is perpendicular to L3. So automatically L3 becomes perpendicular to L1 also. So I will write here, yes. Therefore, L3, L1 is an element of R, implies that L1, L3 is also belonging to R. So, same thing can I say for L6 and L7 also? L6 is perpendicular to L7. So, automatically L7 becomes perpendicular to L6. So, I can write here, yes. Therefore, L6, L7 is an element of R, implies L7, L6 is also an element of R. So, the relation R is symmetric or not? If A is related to B and it implies that B is also related to A, then we say that the relation is symmetric. So, if I got L1 is related to L2, then it means that L2 is similarly exactly same way related to L1. Therefore, the relation is symmetric. So, I write here, yes, it is symmetric. Come to the transitive relationship. L2 is perpendicular to L1 and L1 is perpendicular to L3. Does it imply that L2 is perpendicular to L3? Let us check. I know that L2 is perpendicular to L1 and L1 is perpendicular to L3. Does it imply that L2 and L3 are also perpendicular to each other? No, clearly I can say they are not intersecting, rather they are parallel to each other. So I write here, no. It means that if L2 is related to L1 and L1 is related to L3, it does not mean that L2 will also be related to L3. Or if L2, L1 is an element of R and L1, L3 is an element of R, it does not imply that L2, L3 is also an element of R. In fact, it is not an element of R. Hence, I can say that the relation R is not transitive. So I have got that relation R is not reflexive, relation R is not transitive, it is only symmetric. So I can say that it is not an equivalence relationship. So what is the pasting work? Let us see. You can take a plain colored sheet and you can make the lines on it. Or else if you want to make the work creative, like this is the work done by one of my students, Unnati. She's instead of just marking the lines, she has used colored threads. And using colored threads, she has done the work very creatively, made the lines L1, L2, L3, L4, L5, L6, L7, and L8. So this is another way of doing it. Let us write the application. The application is that the activity can be used to check whether a given relation is an equivalence relation or not. So I hope my first activity is clear to you and it's going to be helpful to you. Keep watching. Do not forget to subscribe my channel. Thank you.